All right, everybody. Back in business here, looking at 3-4. Hopefully you've been keeping up with our in-class and outside of class stuff chronologically. 3-1, 3-2, 3-3, 3-4, our at-home assignment about remembering properties of logarithms. Okay, so remember a logarithm is another way of writing an exponent. So there's exponent rules with exponents. And of course, those rules will translate to logarithm rules. So here are a couple that I have written down here for the exponential side, and a couple things that I have written here. Let's look at this first one. We know that when we take a product of two numbers of the same base, and that's what we really want to concentrate on the writing to the right that I have here. Numbers of the same base, when multiplied together, you add the exponents, right? And that shouldn't be a big deal. Actually, sometimes they screwed up with numbers. Of course, we know x squared times x to the third is x to the fifth because it's x times x times x times x times x. There's 5 x's being multiplied together. So this is the exponent rule. Numbers of the same base, when multiplied together, you add the exponents. Concentrate on that sentence when we talk about um, logarithms, which is just an exponent. It really is. Logarithms are different ways of writing exponents, so they will follow exponent rules. All right, enough of that. When you divide numbers at the same base, you subtract the exponents. And actually, I think I wrote this one up here. X to the ninth over x to the fourth. Sure, it's x to the 9 minus 4, which is x to the fifth, but look at what happens. 1, 2, 3, 4, 5, 6, 7, 8, 9 x's over 4 x's. 4 of them cancel. You have 5 x's left over on the top. That's x to the fifth. So that's where that rule comes from, just like covering that one more time. Blah, 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 blah. So numbers of the same bases divided, you subtract the exponents. Remember that verbiage. And in a power raised to a power rule, x squared raised to the third is x to the sixth. Students often screw up these rules because they're coin flippers. They try to remember the rule and then apply it to the wrong side. That's why I give reasons real quick that can take just a second. Wait, what does x squared raised to the third mean? It means x squared times itself 3 times. That's how I get the x to the sixth, so therefore multiply the exponents. Alrighty. All right, so it may be a stretch, but it isn't. Here are the logarithm rules. I'm going to zoom in on them and then zoom out to the sentence. I'm going to use the same verbiage when I read this logarithm. Numbers of the same base, when multiplied together, you add the exponents. And yes, log base b of r, log or s, I'm sorry, but let me look at this one. Let's go with log base b of r. B to what power equals r? When you evaluate this, or if you had a chance to evaluate this, the answer is in exponents. And b to what power equals s? That's how this reads. The answer to this is an exponent. What are you doing with these two exponents? You're adding them. So it is numbers of the same base being multiplied together, add the exponents rule. And then numbers of the same base being divided, you subtract the exponents. And yes, same thing. This represents an exponent, and this represents an exponent. It does. B to what power equals R? The answer is a power. B to what power equals S? The answer is a power. And you're subtracting those powers. And then this is a bit of a stretch, but I'm going to erase this real quick. Well, I can't. I have it stuck there, but this is a power raised to a power rule. So log base b of r, this is an exponent raised to a power. You multiply those, or this is a number raised to a power. You multiply these two exponents. So that one's a bit of a stretch, but c is an exponent. And guess what? Log base b of r is an exponent. And what are you doing with those exponents now? You're multiplying them. So I use the same sentences because they do apply, because logarithms are exponents. So they will follow the exponent rules. Whatever you need to do, you got to get these memorized. And according to, one of the teachers in CAT, you did this a lot in Math 3. Okay, this was a huge component, so this is not brand new. All right, so do understand that this side is condensed or writing as a single logarithm. This side is expand or write it as multiple logarithms, and that's all this section is. It's playing the game of condensing or expanding, and then hopefully you're able to do that. So keeping it real simple here. Okay, assuming x and y are positive, use properties of logarithms to write the expression as a sum or difference of logarithms or multiple of logarithms, or it could just say expand. So it's taking this side on the left and turning it into the side on the right. So from condensed to expanded. All right, and I'll show the first couple here. So this first one, ln of 9 times y. By the way, remember, ln is just log base e. Really get that hammered down. It's just a notational thing. Mathematicians are lazy. 4 letters, now we can write it as 2, and then we just saved 0.5 seconds of our life. But just remember, that's what ln is, and it's just a logarithm of a base e. And it's just Mickey Mouse stuff, man. ln 9 plus ln y. There it is, a product. So numbers of the same base multiplied together, you add the exponents. Just having the ability to do this is really the key. And then when we move on to solving equations coming up next week, these rules are going to come into play and you got to know when to use them. All right, we should know what this one is. So this is a perfect ed puzzle time. What would be the first step? Okay. All right, I stalled for myself so I can make that an ed puzzle question. And that is the first. Now, that is not, say you go to, this is a multiple choice and you go to the final answers, A, B, C, D, and like, it's not there. You don't see this answer like, oh, Mr. Samuels, he's such a jerk. He taught me the wrong thing. I don't see the right answers. It's because this is equal to something. Remember, what is this base right here? Boo, the ghost. And it's log base 10. Oh, here's another ed puzzle. I just ed puzzle you once. At least hopefully you got this answer. What does log base 10 of 10 equal to? 10 to what power equals 10? All right. So the final answer that you'll see probably in a multiple choice is this, because this goes a little step further. It does simplify. So look for that stuff for sure. This one right here, this is the flat out power raised to a power rule, I like to say. Really what you do is you yank that out in front. And I think I didn't, there we go. And that's what we see here. When you have log base b of r raised to a power, you can yank that power out in front, and then you have the power raised to a power rule where you multiply the exponents. And yes, this is an exponent. -2 times this is an exponent. Log base 2 of x. All right. And I think that's all we have to do about that. Yeah, just trying to think about this one. And be careful where all the cube roots are. So it is a cube root of both of these. So you have a couple things you could do with this. I think the smartest thing to do first is do the subtraction rule. And they both have a cube root on them, so that's all good. Oh, and we should have wrote 2 steps in one. This is not going to be an acceptable final answer because when you expand, and this is where these rules get a little hairy. We don't know our exponent rules, and therefore we're going to have a problem with doing logarithms. A lot of times people struggle on logarithms because they don't know this rule. The cube root is the same thing as the 1/3 power. All right. And that's true. And all I can say is, we talked about this in chapter PR for sure. I know it was one day in a flash and moved on because PR was a review, PR prerequisite chapter. And then, sorry, we could pull out the power 1/3. Another way that could look if we took a different approach to this, sure, it's meaning 1/3 is on both of these, so you could distribute it out. If you did this a different way, this would be the result. If you made this one big cube root to start off, blah, 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 blah. unnecessary step. I just like you to be aware that there's possible different answers there. Okay, showing these rules yet again, because now we're going to play the game of going in reverse. Okay, so we have expanded, and now we want to condense. Oh, we should be able to get the first one right. So what does that emulate the most? The first, the second, or the third rule? All right, and it's the first rule. Log, by the way, what's the base on this logarithm? Log, I don't see anything here. Boo. And then it's 5x. ln, what's the base on ln? That's not really a proper way of saying it. It's log base what equals ln. Ooh, I should put this in the ed puzzle just to see if you've done anything up to this point. All right, so that should be something that we were able to write. And then this is just ln of x divided by y, not ln of x over ln of y. No, single logarithm. Subtraction rule means divide, I guess is the best way I could say that. I don't know if I said that perfectly right, but basically you got to get to know the rules and do them correctly. First thing is that 4 becomes a power. And then we can go ahead and divide. Single logarithm, y to the fourth over z, not log y to the fourth over log z. We will see something like coming up, but it's called the change of base formula. Okay, flying along, because again, we're supposed to have this down and know this at least and say, okay, I remember this from last year. We spent a lot of time, according to one of the math teachers, on this. Okay, so notice this is all expanded out. We want to contract it or condense it. So these three, or that 3, sorry, becomes a power. So yeah, you're going back and forth. Just in the point, what's the point? The point is to get these rules down so that we can use them to solve situations, solve equations. We need to know these rules in order to solve logarithm equations. So this is a wax on, wax off kind of situation. You'll find out. And yes, you want to distribute those powers using the power rule. Sorry. Sometimes my throat gets irritated when I talk. I can imagine you get irritated when I talk too. Sorry. That's the case. Z to the fourth. All right, and then we use the subtraction rule. Can't use it early. We got to make sure we get all these exponents taken care of before we do the subtraction rule. And I'm going to write this ln real big because it's not ln over ln. It's ln of a fraction. And then we got some basic rational function simplification. These y's should cancel. And a final answer is, in simplified form, x to the 9th y over z to the 4th. So I want to make sure I did everything right there. Square, square, yep, y squared, z to the 4th, y to the 3rd, x to the 9th, just triple checking. There it is, condensed into a single logarithm. Went over probably the directions super fast, but it says use properties to write it as a single logarithm or condense, right? The variables being positive, we don't have to worry about absolute values. And I don't even want to go over that in our shortened time together, so we're just going to leave it be. All right, and then there's something that's called the change of base formula, which is kind of losing its use as the calculators get more better. Well, that's good English, huh? So we know at this point that you can, when they ask you to do log base 4 of 7, I'm stalling as I wait for my calculator to open. Ooh, like choosing students there. We have a log button. That's a log base 10. We have an ln button. That's a log base E. We don't have a log base 4 button. So this is asking 4 to what power equals 7? 4 to the first is 1. 4 to the second is 16, which should make sense that we get an answer between 1 and 2. Right? But I don't have that button. So what do I do? Back in the day, there was no choice. You had to do what was called the change of base formula, which is log 7 the answer part, divided by log 4 the base. This is called the change of base formula. And that's how I get that 1.403 blah. You could also use the ln button and do ln 7 over ln 4, ln of the answer over ln of 4. And I will do that and show that you get the same answer. 7 divided by ln 4. And this is just something you have to have memorized. There you go. And there are no other logarithm buttons with different bases. You only have log 10, log base 10, and log base e. But the calculator's got all fancy schmancy, and they gave you some new possibilities. And it's now alpha, and I shouldn't even show you this. So don't ask me in class, hey, where was that button? All right, first of all, pay attention. It's alpha window, and then it's number 5. And now we get the change of base formula, or not that. We can actually use any base logarithm and type it in as it is and press enter. So now you spoiled brats with these new calculators. You don't even need to know the change of base formula. Well, you do still. So that's where the calculator becomes bad, when you start using it too much and not, oh, I don't have to listen to this. So I got this button. Well, there are other applications to the change of base formula. So you do and should still know how to use it. Okay. So instead of doing log base 5 of 19, you should do, and it is actually faster. It's faster to just do log 19 divided by log 5. And by the way, what should we expect for an answer for this? It's good to think about that, because at least we're thinking logarithms. 5 to what power equals 19? What should your answer be between? Perfect Ed puzzle. 5 to what power equals 19? What should your answer be between? All right. And the answer is 1 and 2, because 5 to the first is 5. 5 to the second is 25. There you go, 1.8929. And then 12 to what power equals 259? Think about that for a second. What should that answer be between? Yeah, sure. I'm going to let that happen, because you should know your times tables. Lexi Samuelis knows her times tables up to 12. So why shouldn't you? Arr. All right. All right, so log, I keep trying to look at it, 259. So let's do ln now. Ooh, this is crazy. 259 divided by ln. Don't do ln. It's got to be the same base, whatever. If you choose log all the way through. If it's ln, choose ln all the way through. The logarithms have to have the same base for the change of base formula to work. And you should have said between 2 and 3, because 12 squared is 144. So 12 to the third is really large. So between 2 and 3 would get us what power on 12 would equal 259. I won't be a jerk about this one. Hard to mentally think about that one. 29. So log 29 divided by, oh, my memory, log 0.2. Log 0.2. Entry. Okay, negative 2.09. So you get a negative exponent. We can explain that. 0.2 is 1/5. So I need to flip it. That's why it ended up being a negative exponent. So 1/5 to what power equals 29? Close to negative 2. 1/5 to the negative second power is 25. So that's people that really try to understand what's going on with stuff. All right, perfect Ed puzzle. I'm going to ask you 8 Ed puzzle questions, because this is what I would do in class. Common errors. This is the true false section. We're going to review or do every single one of these. And I'm going to Ed puzzle you on every single one of them, starting with 1. Is 1 true or false? Here we go. And the answer is, that is a falsaroonie, man. That's a made up situation. There's actually nothing you can do with this. I'll tell you what ln of x plus ln of 2 would have equaled. It would have been ln of 2x. See, that's the product rule. Change that to 2 logarithms sum. Add the exponents. Those represent exponents in both cases. So that's what the true rule would be. That is not what you have there. Oh, this is fun. Number 2, true or false? And the answer is falsaroonie. All right. there's two ways of looking at this. Either this is log base 3 of 7 plus log base 3 of, that's true, using the sum rule for a product turning into a sum of two different logarithms, or this is equal to log base 3 of x to the 7th using the power raised to a power rule. That is not what's going on with this at all. So this equals this equals this. These two do not equal. Isn't this fun? Next one. Log base 2 of 5 times x is log base 2 of 5 plus log base 2 of x. True, that is actually the rule. That is the numbers of the same base multiplied together. You add the exponents. All right, I'm using the verbiage of exponents, how they relate to logarithms. True or false? True, that's one of the rules. All right, nothing else to be said about that. Numbers of the same base divided, you subtract the exponents or separate it out there. Lost my words there, what I wanted to say. But anyway, number 5, true or false? Ooh. And the answer is that's a falsaroonie. This is one of the biggest mistakes people make. Log of x divided by 4 is log x minus log 4, not this. And sometimes people write this and write it like that. That is incorrect. This is actually the change of base formula. You know what this actually equals? This actually equals log base 4 of x. And then you'd have to use the change of base to evaluate that, even though you can't really evaluate that. So that's a change of base formula we just showed you, or this is equal to that. It's just proof that those are not equal. Next. And the answer is that's a rule. That's one of the basic rules that we have. Okay, pull that exponent out in front and you're good to go. Ooh, interesting. Okay. And the answer is false. What this is equal to is 2 log base 5 of x. And then you might think that's what that equals. No. I don't know what else you could do with this. I guess you could make this in your head log base 5 of x times x, because that's what x squared is equal to. But then that equals log base 5 of x plus log base 5 of x using the product rule equals a sum of two logarithms. So that is not true as well. And why I like this thing is this is common errors. Common errors where students make up logarithm rules. Then last but not least, the absolute values are really not what's important in this. Really focus on this and then this. And the answer is that is the rule. That is the product rule turns into a sum of two logarithms. Okay, so common errors. Hopefully you got an 8 out of 8. Hopefully you at least got 6 of these right as you move through. Good stuff to end this on. All right, got to end the old video here.